Here we are at our worksheet, and I want you to know I want to point out first a couple of changes that I've made to your worksheet. First of all, I changed the acceleration of gravity I rounded it up to 10 meters per second squared. I think that will work out a little easier when you go to do the graphing. And then since I wrote my equation of motion in terms of dx and dy, I changed the variable names on my data tables. I added some grid lines for the table, and added the time in seconds in this column here. What I've done next is to write my equations up here above my data table. dx is equal to 20t and dy is equal to 5t squared. And now I have everything that I need in order to start completing the data table. The first data table is for the baseball that's being dropped off of the cliff, and the second data table is for the cannonball that's being shot off the cliff. The baseball is just a little more simplified because there is no direction in the x-axis. So for the baseball, we're only going to be looking at dy. So I'm going to help you get started on this data table. So if I take the value for t at t equals 0 and plug it into the dy equation, 0 squared is 0 times 5 is 0. So at time 0, dy is 0. At time equals 1, then I plug t equals 1 into this equation, and 1 times 1 is 1 times 5 is 5. Okay? And then for t equals 2, you plug t equals 2 into the equation, and you get... So go ahead and fill out the rest of this data table for dy. Okay, you should have calculated these values for dy for these times. I got 0, 5, 20, 45, 80, and 125. These are meters. So at t, the last one here, at t equals 5 seconds, I got the baseball had fallen 125 meters. You can use this same data in the next table because the t values are the same and the equation for dy is the same. So why don't you go ahead and fill out the cannonball table for dy. Alright, so here we see the same data in this data table. We just need to add the dx. Now remember, dx is the cannonball traveling off in this direction. So dx is equal to 20t. So at t equals 0, then dx is equal to 0. At t equals 1, then dx is equal to 20. All right. At t equals 2, 2 times 20, dx is equal to 40. And I believe I see a trend here: 0, 20, 40, 60, 80, 100. Okay? So we have our data tables completed. Alright, let's see what this looks like when we plot it out. Here is the baseball being dropped, and we're going to show the baseball at time equals 0. So this is time equals 0. And then the baseball at time equals 1 is 5 meters. Here's the baseball at 5 meters at t equals 1. And then we're going to show the baseball at time equals 2 here at 20. Okay. Why don't you stop the video and go ahead and plot where the baseball is for t equals 3, 4, and 5. All right, your graph should look like mine, showing the location of the baseball dropped vertically at time equals 1, time equals 2, time equals 3 here at 45 meters below the top of the cliff, time equals 4 at 80 meters below the top of the cliff, and time equals at time equals 5, the ball hits the ground at 120 meters. Okay. Now the next step is to plot what happens to the cannonball. But this time you're going to have motion in the x direction and you're going to have motion in the y direction. But the nice thing is that you already know where it's going to be at in the y direction. So you could take a ruler and use that as a guide to show your y locations at each time. But that'll be a y location with some x direction. So let me do a couple of them to start you off. So at time equals 0, it's x equals 0 and y equals 0. So the cannonball has just now left the barrel. At time equals 1 second, the x distance is 20, so somewhere on this line, and the y distance is 5. So y is 5. I'm going to have to kind of estimate if halfway down is 10 and then half again. That puts the cannonball about right there. Okay, I'll do one more with you. At t equals 2, then the x direction, it's gone out to 40, and in the y direction, it's come down to 20. Okay, so we already see that the cannonball is progressing in the x direction at a constant velocity, but is now beginning to accelerate in the y direction, downward. Okay, why don't you fill in the rest of those points using your data. Now you've plotted your points, and it should look like this. And if you connect the dots showing the trajectory of the cannonball, it should look something like this, a nice curve. All right? So that's what I want you to do to complete the worksheet. What you need to do is answer the questions below the graph. I think that now that you've gone through this exercise, you'll be able to answer those questions.